Hey everyone, this is the second half of section 4 for chapter 4, solving logarithmic equations. And in my opinion, I actually think solving logarithmic equations might be a little bit easier than the exponential, but you can watch this video and find out for yourself. So let's dive right into it. As I talked about before, we targeted the first 3 goals in our last video. We're going to target 4 and 5 learning goal today. With this video, solve logarithmic equations with and without your natural base e and natural log of x. And using the additive, also, I forgot to edit this, all the different properties we've looked at for logarithms to solve equations. So if we take a look, remember that when you read logarithms, we're looking at x minus 1 as our base. When we read logarithms, you can take x minus 1 being raised to the 4th power equals 81. So this is very similar to the first problem we did in our exponential video. But if we take a look, I gave us steps again to try and see which of these could be equivalent to this first statement. And if we look, x minus 1 raised to the 4th power equals 81 is by definition what a logarithm is. So we're going to first use this step. So I have my base of x minus 1 to the 4th power equals 81. Now, to solve this, you could take the 4th root of 81, but we also know that if I rewrite 81, we could rewrite it as 3 to the 4th. So x minus 1 to the 4th equals 3 to the 4th. And instead of before having our bases being equal, right now we have our exponents being equal. So I can state x minus 1 equals the base of 3 since my exponents were the same. So now if I add 1, I get that x equals 4. Now, not all logarithms can be written that way. So if we take a look, we have a base of 2 being raised to the 5th power that equals x plus 4. So 2 to the 5th equals x plus 4. Now 2 to the 5th and x plus 4 aren't the same base, but what we can do is evaluate 2 to the 5th. And as we know, 2 to the 5th power equals 32. And that equals x plus 4. This is just a basic linear equation now. So I get that x equals 28. It's important to double check that what you're taking a log of is never negative. 28 plus 4 is 32, and that's not a negative number that we're taking a log of, so that's our correct solution. When we have logarithmic equations with our natural log, remember that natural log has a base of e. So if we take a look at this, I can write e to the 2nd power equals x. It's outlined right here for us. Log with base b of y equals x can be written as y equals b of the x. So we also remember the value of e is about 2.718. So we have e to the 2nd power equals x. Now to evaluate this, you can use 2.718 to the 2nd power, or you can use your e button in your calculator, and we're going to get that x equals 7.389. I don't know if that decimal is pretty clear. There we go. Just like before, oh, I lost my minus sign. What you want to do is isolate your logarithm before you start. So I'm going to add 5 to both sides. So I have 2 times the log of base 3 of x equals 7. Now, there's 2 different ways of doing this, but what you can do is say I divide by 2. So I get log with base 3 of x equals 7 over 2. Don't be afraid of a fraction. Then we're going to rewrite this to be that x equals 3 to the 7 over 2 power, which we know to be the square root of 3 to the 7th. As an exact answer, remember 2 goes into 7, excuse me, 3 times. So this is the same as saying, 27, right? 3 to the 3rd is 27. Square roots of 3. As a decimal approximation, you can just use your calculator and you will get x is approximately 46.765. All right, let's look at our next problem. Remembering that our product property, or when logarithms are being added, we can use our quotient property. So if we take a look, which of these outlines the same example? So this, we want to be careful that we have the same base. So our base is 2. This has a base of 2. This has a base of 2. This is a base of 4. So that's not going to help us. And we're equaling 5. So not this one either. So this one is going to be helpful to us because it's our product property. So we have log with base 2 of x times x minus 4 equaling 5. Now what you can do is do 2 to the 5th equals x times x minus 4. You can also multiply this out, so you end up getting a quadratic equation, which is fine. So x squared minus 4 x equals 2 to the 5th. So x squared minus 4x equals 32. When you're solving a quadratic, again, you want to make sure that it equals 0, so minus 32. And then factors of negative 32 that add to negative 4 is 8 and 4. Well, sorry, negative 8 and 4. So I get that x equals positive 8 and x equals negative 4. Now we have to go back and check our work. Log of 8 is going to be fine, and log of 8 minus 4 is going to be fine because that gives us positive. When I plug in negative 4, 2 to what power gives me a negative is not possible. So this is an extraneous solution. This is my only solution. So just be careful to always double check your answer. Logarithms, x cannot be negative. All right, here I have a natural log, both the same base because our base is e. With subtraction, we have the quotient property. So I'm going to write natural log of x over x plus 1. This is one full logarithm equals 1. Now my base is e. E to what power gives me x over x plus 1? So I can rewrite this as x over x plus 1 equals e to the first. And now we can solve. We know that x can never be negative 1 because of x plus 1 in my denominator. We don't ever want that to be 0. And now we can solve. E to the first, as we know, is e times x plus 1. And we can distribute. And we can subtract e. So I have x minus ex equals e. Factoring out x. 1 minus e equals e. So x ends up equaling 1 equals e divided by 1 minus e. You could have also just evaluated this and solved, but remember you want to factor out to get one single x. And when you do that, we have e divided by 1 minus e. And with our calculator, we get that x equals negative 1.58. And unfortunately, this is where we're going to have no solution because we have natural log of x, and we can't have a negative number. All right, one of our last problems we're going to do together. Notice we have natural log on both sides of the equation. So when I condense, I'm going to end up getting the natural log of x minus 3 equaling natural log of 7x minus 23 divided by x plus 1. Since natural log is on both sides, just like we could take the natural log on both sides, we can cancel it out on both sides because it's equivalent. Technically, we're raising both sides e to that power. So I get x minus 3 equals 7x minus 23 over x plus 1. We need to restrict our domain to know that x cannot equal negative 1. And then we could solve. So I'll get x squared. When I multiply x plus 1 to x minus 3, I get x squared minus 2x minus 3 equals 7x minus 23. And now we want to get everything over to the other side. So I get x squared minus 9x. And then we're going to add 23. So I get plus 20 equals 0. Factors of 20 that add up to negative 9 give us negative 5 and negative 4. And so x equals 5, x equals 4. Let's check. 5 minus 3 is 2. That's fine. 5 times 7 is 35 minus 23. That gives us a positive. And 5 plus 1 is a positive, so that works. 4 minus 3 is 1. 7 times 4 is 28 minus 3. That's still positive. And 4 plus 1 is 5. So both of these solutions work. I hope you find today's video helpful and everyone is doing well. And if you have any questions, as always, email me. Have a good one, guys.